Electromagnetic. This video is centered around the topic of electromagnetism. This is a fairly complex topic that can be defined as the interaction of electric currents and magnetic fields. Throughout this year in physics, we've gone over many topics that allow us to comprehend electromagnetism. A quick review involves electrostatics, the study of electric charges or fields or interactions between charged particles. Magnetism, a physical phenomenon produced by the motion of electric charge resulting in attractive and repulsive forces between objects. Linear kinematics, linear motion with respect to time. Linear kinematic quantities include distance and speed, and the vector quantities of displacement, velocity, and acceleration. Kinetic energy, energy that a body possesses by virtue of being in motion. Now, on to our science guys.
Hi, I'm Michael Esposito, the Science Burrito. Now, have you ever wondered, what are the physics behind a Gauss rifle? Well, probably not, so that's why we're going to explain it today. So, say you have a Gauss rifle, right? You know, like what is this? Well, so what happens is, we're just going to place this right here, and we need something to shoot out of this, so lucky for me, I happen to have a small projectile, right? What I'm going to do is I'm going to attempt to take this and use magnetism to move the projectile, right? Don't have a... So we take this battery, you see, okay? And what happens is I'm just going to connect positive to positive, negative to some other side, generating current through this wire, and it sucks it right up.
Hi, I'm Ben Scarborough, the Science Taquito. Now, you may be wondering, what are the mechanics behind this neato little device? Well, how it works is you've got this piece of pipe that's not magnetic, it's not made of metal, wrapped in a copper wire. And when you put a projectile, like this, in here, if the projectile is magnetic and you run a current through the wire, it creates an electromagnetic field. And when that field is created, if you follow the right-hand rule...
Yes, the right-hand rule. The right-hand rule is used to explain which way the current is going depending on the electromagnetic force. So let's say you have the right-hand rule, and you have the electrical current going around in a coil, right, in a circle. Well, by using the right-hand rule, we can predict that the magnetic force will always point in a straight line.
You'll be able to know that since the coil is going this way, the projectile will be moving this way, like so. This is because the electromagnetic field is pointing this way. Now, typically, a coil gun has more than one electromagnet on it. It'll be multiple series of copper wires wrapped around one long pipe. And what this does is it allows the projectile to be accelerated through a series of multiple electromagnets over a long distance, greatly increasing its acceleration. A coil gun propels a ferromagnetic projectile by sequentially activating a series of electromagnetic coils arranged around the projectile's path. The projectile is pulled towards the center of each coil by the magnetic force of the wire's current. Immediately before the projectile reaches the center of each electromagnetic field, the coil's power is cut off, and the next coil in the series is given a current. This creates constant acceleration for the projectile and can reach extremely high velocities. In a historical sense, the first coil gun was created in 1933, when Texan inventor Virgil Rigsby developed a stationary coil gun that was designed to be used like a machine gun. It was powered by a large electrical motor and generator, and appeared in many contemporary science publications.
Hi, I'm Ilam Silva, the Science Tortilla. Here are some of the variables you'll need to know to keep up with us during this video. H, magnetic field intensity. I, current. N, loop density, which basically tells us how many times the coil loops within a specifically assigned area. B, magnetic field. L, arbitrarily assigned length. W subscript M, energy of the electromagnetic force. So you have just seen how our nifty coil gun works, but how do we explain this physically? First, we must delve right into Maxwell's equations, the first of which is amperes. Ampere, do you mind giving a little bit of an explanation? What he just clarified for us is that his equation is the half integral of magnetic field intensity times the derivative of the length is equal to the current enclosed. We can simplify this into H equals current times wrap density. This all comes into a bigger spectrum when we're able to take the length times the current squared and have it to give us a half mass times velocity squared, which allows us to manipulate and derive to get the velocity of the projectile, which is our initial goal.
Now that we've gone over the physics involved in a coil gun, let's talk about some potential applications of this device. Applications for this lie, for starters in the military, you can have what we call a Gauss rifle, which is a launcher or rifle made of these electromagnetic coil guns. This provides a silent and very efficient yet very, very powerful way of moving a projectile, such as artillery or even a bullet from a conventional rifle. You've also got the transportation applications. You could move any cargo as long as it's encased in a magnetic material from point A to point B very efficiently using the electromagnetics in a coil gun because this is accelerating it along the pipe. And finally, NASA has released plans on using coil guns to launch materials to the moon in support of lunar colonization. Environmentally, this also has another application through the removal of nuclear waste from the planet. It could be feasibly accelerated through a coil gun and launched into the space. Launched into space. Of course, this is also preferable to conventional methods of propulsion because it does not burn gases. It is very environmentally efficient as well as powerful and equally potent.
Today, we've gone over the potential applications of coil guns and the electromagnetic mechanics behind these devices. However, there is much left to be explored. Electromagnetism is an extremely broad topic. We encourage you to go out and learn more about this fascinating subject.
Faraday's law of induction, the law of all sea and all land. No lies, no deceit, no corruption, in this law so complete and so grand.